So we're going to apply what we learned about condensing logarithms into solving for x. So when you solve for x, you should end up with a number, an x equals something. Our first step is to condense the logarithms. So when I have addition between two logs, that's going to be multiplication within a log. So it's going to be x times x minus 12 equals 3. I next want to get rid of the word log by rewriting it as an exponent. So 4 to the third power equals x squared minus 12x. I just went ahead and distributed. 64, that's 4 cubed, equals x squared minus 12x. Now because it's a quadratic, I need to set it equal to 0 and then try to factor it. So 0 equals x squared minus 12x minus 64. Here's where you have to think about what two numbers multiply to negative 64 but then add to negative 12. So, and it could take you a little bit of time. Negative 16 times 4 is negative 64. Negative 16 plus 4 is negative 12. Whatever I figure out for the top has to also work for the bottom. So once I have those two values, I can go ahead and factor. X times x is x squared. That's my first term. And then a negative 16 and a positive 4. If I FOILed this out, I would get back my equation, x squared minus 12x minus 64. Set each little factor equal to 0, solve for x, and I'm going to get x equals 16 or x equals negative 4. But keep in mind, with logarithms, you can't have a negative argument. So if I plug back in the number negative 4, back in here, log base 4 of negative 4 doesn't work. The argument is negative. If I take the number 16 and plug that back in, so log base 4 of 16, the argument's positive. 16 minus 12, that argument is positive as well. As long as all arguments are positive, that number's good to go. Right. For letter B, there's another addition sign. So this is log base 9 of, and we're going to multiply, x minus 5 times x plus 3. You're going to have to FOIL now the inside. X squared plus 3x minus 5x minus 15. That's first, outside, inside, last. Combine your like terms. Okay, watch your signs there. Positive 3, negative 5. And now, again, to get rid of the log, you need an exponent. So you bring down the base, power equals x squared minus 2x minus 15. 9 to the 1 is just 9. But before you go and factor, again, you've got to have this set equal to 0. So I'm going to subtract 9 from both sides. All right, get minus 24. And then we're back to what multiplies to negative 24, but what's going to add to negative 2. So I'm thinking a negative 6 times 4 and a negative 6 plus 4. So minus 6 plus 4. Set each of those factors equal to 0. Solve for x. And we get x equals negative 4 or x equals 6. And again, taking your number 6, 6 minus 5 is 1. 1 is positive. 6 plus 3 is 9. 9 is positive. So 6 goes good. If I plug in the negative 4 though, negative 4 minus 5. The end result is a negative 9. I can't have a negative argument, so negative 4 is canceled out. The only solution is x equals 6. Again, same idea here. Condense with addition, we're going to multiply. So it's x minus 2 times x plus 1. So log base 2 of, FOIL that out, x squared plus 1x minus 2x minus 2. Log base 2 of x squared plus 1 minus 2 is a minus 1x equals 2. All right, get rid of the word log, bring down your base to the power equals x squared minus 1x minus 2. 4, that's 2 squared, x squared minus 1x minus 2. Degree 2, so I've got to subtract the 4 from both sides, make a 0 over there. Minus 1x minus 6. All right, so from here, you need to figure out what is going to multiply to negative 6, but then add to negative 1. So I have a negative 3 times positive 2, a negative 3 plus 2, and I can go ahead and factor. Set each of those little parentheses equal to 0, solve for x. And once again, you got to check your answers, and it seems to be like, well, that negative answer is probably not going to work. Yeah, there's a good chance that one's not going to, but it's not always. So you do have to check. If I plug in the 3, 3 minus 1 is 2, or 3 minus 2 is 1, 3 plus 1 is 4. So positive 3 is good. If I plug in negative 2 minus 2, the end result is negative 4. So I can't use that one. And the last one on this page only has one logarithm, but it's not by itself. So I have to add 2 to both sides, keeping in mind that the base is 10. Now this is a little bit easier problem because all I need to do now is just drop the log, bring down the 10. Squared equals 3x plus 2. 100 equals 3x plus 2. And now this isn't a quadratic, so all I need to do is just get this x by itself, subtract 2, and divide by 3. 98 thirds. When you plug 98 thirds back in here and multiply it by 3, it's going to be a positive number. And a positive number plus 2 is still going to be positive. If you want to fully check it, you can type it into your calculator and look. But as long as the argument's positive, it should be good to go.